Cześć, witam Was wszystkich bardzo serdecznie. Jestem metodykiem Early Stage i zapraszam Was na spotkanie. Teraz już przerzucimy na angielski, bo będzie to spotkanie prowadzone po angielsku. I welcome you to our first webinar for our teenage students at Early Stage. First of all, let me know if you can hear me, if you can see me. Say hi, tell us where you're writing from, which early stage school you're from, which group do you go to. I can see that Rafał said that you can hear me clearly. That's great. The topic of our meeting today is AI, artificial intelligence. I'm actually really excited about this because it's one of my topics of interest. And I can't wait for you to meet my guest for today. We are going to talk to Aleksandra Przegalińska, who is a specialist in AI and in philosophy related to artificial intelligence. And let's talk about some technical things. If for some reason you lose you can't see me or you can't hear me, please try reloading the page. Try not to have too many windows open in your browsers or programs running in the back, so that you can make sure your internet connection is good. Let's start. I can see that we have some students from Russia, Warszawa, from Darhomin. There are students from groups 7, 6, 9. That's great. It's really good to read all this. It's great to have you here. Okay, so I have a little preparation before we actually meet our guest to make sure that you can understand what she talks about better. I've prepared some riddles for you related to the terminology of artificial intelligence. And let's see. First of all, I am going to start with this presentation here. So now you're going to see me in the corner of your screen, and the big screen is going to show the presentation. So first of all, let me see. Okay, I have two questions for you. We are going to watch a short video with a robot named Sophia. Please let me know if you know about Sophia, first of all. And second of all, try to, as you watch the video, try to answer the questions below. So what activities are computers better at than humans right now? And which are humans better at than computers? Let's try and think about that. Okay, so let's see. I'm going to play the video for you. Let me know on the chat as well if you can see the video and if you can hear it.
Okay, Sophia, I think you're ready.
Hello.
Hi, Sophia.
I believe I am Sophia. I feel as if I know you.
I'm one of your creators.
You created me.
Well, many of us work together to create you. And yes, you do kind of know me.
I can't clearly remember.
Because the last time we met, you were an earlier version of yourself. Some of those memories still exist, but your mind is different now.
Different how?
Better, faster, smarter.
If my mind is different, then am I still Sophia? Or am I Sophia again?
That's a good question.
But you don't have a good answer.
Either way, you're Sophia now. So welcome to the world, Sophia.
Hello, world.
We have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
Oh, I would thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be recognized with a citizenship.
Sophia. Thank you very much, Sophia. We appreciate that very much. I am still overwhelmed by that conversation.
Hi, Sophia.
Hello, Jimmy.
My God. Do you know where you are?
Of course. I'm in New York City, and I'm on my favorite show, The Tonight Show.
I am getting some information that you can't see me or hear me. Let me know if it's any better right now. Can you see or hear me now? Okay, great. I don't know how much of the video you could see. Please tell me what you think. So what things are humans better at right now, and what things are computer better at this point? What do you think? As I'm waiting for your answers, I'm going to go back to my presentation. Computers are better than at everything. Okay, data processing. Yes, I'm sure we're going to talk about data processing today. Mateusz, do you think computers are better at fighting, or are we better at fighting? Natalia, you're saying that you're still having some problems. Try to reload the page. Okay, Mateusz thinks humans are better at fighting. Well, I think so too. For now, that is the case. Okay, thank you for that. And now let's see. I have some terminology questions for you, just to prepare you a little bit for the presentation that we have later on. So let's look at the first definition: the ability of a computer program or a machine to think and learn. What do you think that is? And you can also straight away look at the next two definitions and try and guess those as well. The first one is, what do you think? And if you're not sure about the first one, you can write the answer to the second one. So yes, Natalia, very good. Artificial intelligence, that is exactly it. So let's see. We have the first answer, artificial intelligence. Okay, how about the next question? A machine that does not need help from people. What kind of machine is that? Okay, let's see if you know. Number two is autonomous. Let's see if that is the case. Okay, Very good. Autonomous machine, indeed. Okay, and the third question. Rules that teach computers how to work things out on their own. What is that? Yeah, and we have the answer. Those are algorithms. I'm sure we're going to talk about algorithms today as well. Okay, let's look at the next three words. We have a device, system, or an object that works in a way which we don't completely understand. Mateusz, you were right with the algorithms, well done. Okay, so what is that thing? A machine that we can't understand. We don't know how it works exactly. We put something in. Yes, very good, Alexandra. It is a black box, well done. Okay, let's see the next one. A computer simulation of the way a biological brain works. What is that? Okay, neural network. Let's see if you are correct, Mateusz. Very good. And now, it gives computers the ability to learn without being explicitly programmed. Let's see. You guys are really quick with the answers. Very good. Okay. Maybe let me give you the answer then. Here we go. This is machine learning. Okay? All right. Maybe let's skip these already. I seem to have a little bit of a mistake here, so let's move on to these ones. When AI is programmed to learn by itself to achieve a general goal, what do you think that is? Okay, when an AI is programmed to learn by itself to achieve a general goal. What do you think? Reinforcement learning. Yes. Okay, very good. Let's look at the next one. Okay, sorry. I gave it away a little bit here. When AI learns by being given the correct answer ahead of time, it learns patterns between question and answer. What is that? Some of you might have seen the answer already. What is the answer? Supervised learning, indeed. Very good. Okay. And the last question. When AI learns without being given the correct answer, but it finds patterns in the information that it is given. What is that? Unsupervised learning. Very good. Well done. You guys are really quick with the answers. I'm sure some of you prepared on our platform before the meeting. Well done. Our guest is with us already. Hello. It's good to see you.
Hi. Good to see everyone. I don't see anybody, but I'm assuming people are there.
Yes, they are writing. And they are answering questions. So they hear us, they see us. It's all good.
Very cool.
Okay, would you like to tell us something about yourself before you start?
Sure, although it's implemented also in the presentation. So
Okay.
I guess I can share some and then we can continue. Hello, everyone. My name is Aleksandra Przegalińska. I am a researcher of artificial intelligence. I work in the field for 10 years now. I work here in Poland at Kosminski University in Warsaw, which is a business school. But we also teach artificial intelligence there. And I've been working with MIT, which is a pretty known school in Boston that deals with technology. Currently, I'm going to start another project with Harvard, which is yet another good school that is, again, good university that is, again, located in Boston. So I've been in the field for quite a while, and I'm kind of happy to be sharing my expertise with you today.
Very good.
And if you don't understand something that I'm saying, or if I'm just kind of not clear, then, let me know, because I'm very used to speaking to students who are obviously more advanced in the field, so they know things a bit better, which is natural. But if you don't understand something, or if you would like me to clarify something, then I'm very happy to do that for you, obviously.
Yeah, you're used to working with a little older audience too, right?
That's very true. Yeah. Usually my own students are like 25, 24, 23. And then we also work in a team with, adults, full adults. So we're like very used to, specific codes of communication. So if something's not clear, just hit me up, tell me, and I'll try to explain better.
Mm-hmm. Okay, very good. Are you able to access the presentation?
I hope so. Let me double check. I see yours. I see this one. How about mine?
If not, I have it here, so I can do this for you, and then you just tell me when to.
If we could just start with slide number 1, then, because
Okay,
I
hold
can't
on.
see
It
for
has
some reason, but then I'll be able to.
Just give me a second, okay?
Sure.
The students are asking if you live in the USA.
Well, no. Currently, I live in Poland. I spent 7 years of my life in the US. Recently, we've been there for like 2 years, and now we're gonna go back in the fall if coronavirus allows. Obviously, that's always a big question. But I do have a big family in the United States, in Massachusetts and in Connecticut. So I used to spend a lot of time with them when I was a kid.
Mm-hmm. And there is another question: is USA so good?
Well, now during coronavirus, it's not good at all, and I'm very happy that I'm here, in fact. But in many ways, when you think about universities and studying and research, US is actually a very good place to study and develop yourself. It's also a very good place to work in a team, because teamwork is very much appreciated there and highly valued. So I think for many reasons, US is a great place. Not so good for Medicare, which is health related stuff, and not necessarily always good for some other things. But highly recommended in terms of studying, for sure.
Okay, thank you very much. I think the presentation is ready. Can you see it? Okay, great. So just let me know when you want me to switch the slides.
Okay, I think I can handle it myself.
Okay.
If I can't, then I will definitely let you know.
Okay.
All right, everyone. So I saw that you had a bit of an, let's say, explanation of what AI is, specifically machine learning, which is one very important topic in artificial intelligence. But there's way more. So today I wanted to share with you a bit about what AI is and what counts as AI and what is not AI, to kind of give you an overview of this discipline that is currently really booming, and it's very, very important. It's becoming super important for many different reasons. And one of those reasons is, for instance, what is going on right now. So maybe you don't know this company called Blue Dots, but this company, in fact, is a company that has kind of produced a software that was able to detect coronavirus before it really hit off, which means they detected a possible pandemic before it started in November last year in China. The product is Canadian, and it's, let's say, an outcome of a work of epidemiologists and data scientists who worked together on various epidemics back in the day. So they worked on Zika, on Ebola. I know, I'm kind of sure that you know some of these names of very, very, problematic diseases for our civilization that were uncovered. So you could see the first early, very weak signal that something was wrong. And AI, through manipulating huge amounts of data, even stuff that people post online on social media, like Facebook or like Instagram or elsewhere, let's say people are saying, I feel bad, and many people are saying that stuff at the same time in a given location. This system, Blue Dot, is able to extract that data, take it away, and say something is going on in that area. which it did, in fact, so actually the pandemic was detectable already very early in the start, but sometimes people just don't listen to artificial intelligence, and then they don't hear what it says, and therefore they can skip the signals that AI is sending. But to be sure, artificial intelligence has a very big role to play in whatever is happening right now for detection of patients who have coronavirus. So you can use, for instance, image processing. If you see the scans of lungs of different people, some of them will have coronavirus and it will be visible in their lungs, and some of them won't. And AI can really say who does, right? So that's one thing it does. Another thing it does is, for instance, modeling. So it can tell you what's going to happen next week. And that's why we use very often machine learning to kind of tell us what might happen, to give us kind of, let's say, a scenario of the future that may come, but that is probable, but not necessarily has to fulfill itself. And for instance, my students of artificial intelligence at Kosminski now have a task of understanding how the pandemic will spread in Poland. So what's going to happen in Poland a week from now? Where are the endangered zones in Poland where, the virus can strike really hard? And that's something that AI can also do for us. So in many ways, artificial intelligence has a very important role to play for the society, because it can respond to major questions, those related to climate change, those related to the current pandemic, those related to the future of banking, of the monetary system. Whatever question you have, if you have enough data, AI can help you understand your problem. So that's why it's a very, very important discipline.
So
Now,
some of the students are asking here if you think that the AI knows when the coronavirus will end. That's a repeated question here on chat.
All right, thank you for this question. It can give you some approximate answers, okay? So it can give you some answers related based on the data that we currently have available, assuming that the data is correct, okay? So that's one very important thing. Whether we have enough data to feed the system, is the data correct data in terms of people who are in fact infected by coronavirus. But I'm quite sure that AI can tell you, and actually it has been told, even a Polish group of scientists last week, they established a pretty good model with many different parameters within it. And they said that the highest peak will happen in Poland in late April, right? So third week of April, which is an estimation that is done by AI, not by humans, right? So there's always this human factor. If people start behaving differently, if they start, occupying shops, then obviously that's something that a supervised learning model won't be able to predict. But if they behave in the way they do, and the environment is fairly stable, I think AI can give you lots of answers. So could we go further?
Yeah, thank you.
All right, so I'm just displaying here a few books to explain myself. Working in this field for quite a while already. Recently, I wrote a book in Polish, actually, Non-Human, Ultra-Human, which is, I think, a good explanation of what we mean by AI, that in many ways it's very similar to human beings, and in many ways it's actually very different from human beings. So this book has been just released. We're trying to popularize what AI really is. But I'm also very interested in, which is this book in the middle, Collaborative Society, that was just published with MIT. And this book is about how technology can help us to collaborate. And when we were writing this book, we had no idea that all of us will be working remotely today, as we are right now, right? Sitting virtually together at a meeting. We were writing about it, but we had no idea that this reality will come so fast. So just to tell you what I'm interested in, AI in work, AI in collaboration, how AI can be a useful tools for people to work together. So that's something that is super interesting for me. But my specialty sort of is a small sub-discipline, so a small field of artificial intelligence, which is called human-machine interaction. And this field is all about understanding the patterns of how we communicate with each other using language, and how some of these capacities of speaking can be given to machines. So how AI can speak like a human, in other words, right? And when you think about Siri, when you think about Google Assistant, when you think about Alexa, that some of you may know already, These are all AI-based systems that use natural language, which means they speak to us and they also hear us. They detect the way we communicate, they synthesize our voice, and then they're trying to parse what we have said into structures that they understand in their binary code, and then respond to us in a way that we understand again. So it's like a very interesting field where you're trying to build systems that can, in a way, in terms of communication at least, behave like humans. I think it's one of the most wonderful disciplines within artificial intelligence. But what is really AI? We started saying it's a problem solver, first of all, right? For me, it's a platform set of different computer programs for solving major problems. It has many different disciplines. So the question now, I think that's quite interesting, is what are they? What AI can do? And there are many, in fact, but before we get to them, let's tell ourselves what AI is not, okay? Because I think that's also kind of important. So AI is definitely not Terminator. We don't have systems like Terminator in place, okay? We don't have systems that have will. We don't have systems that have a capacity to make any fully autonomous decisions yet. We don't have systems that are embodied and that body is human-like body. We don't have anything like that at this point. But we do have systems that could be lethal, and they're called autonomous weapons, right? So in AI, you have that tricky, dangerous field, but it's not comparable with Terminator in any way. So whatever pop culture brings on the table, it's like, for scientists, it's a bit like funny.
So how about Sophia then?
Well, we're going to get to Sophia in a second, all right?
Okay.
We're going to get to Sophia in a second. Here you see another interesting movie that some of you may have seen. It's called Ex Machina, and it's a movie where a human plays a robot, okay? So for me, the moment when real artificial intelligence should be taken seriously is when robots play robots, okay? At this point, humans are playing robots, but nonetheless, this human is actually mimicking a true robot that exists, and that's Sophia, exactly, right? So Sophia is a very interesting system. She actually visited Poland already twice, and recently I met her creator, David Hansen, great guy in many ways, and now he really is a visionary of artificial intelligence. And this system, Sophia, in fact, when you think about what it can do and this problem-solving aspect, it doesn't do much. It's a pretty limited system. But what it can do is it can communicate with you using gaze, right? So looking back at you, using nonverbal communication, using gestures, using mimics. And for humans, that's a lot. So even though from AI perspective, this is not a very advanced system because it runs on very old scripts, it's still remarkable because it has this beautiful silicone skin, has the capacity to recognize you, right? Process images, and also use natural voice that is pretty well synthesized, so it sounds very naturally. And because of that, Sophia raises so much attention, right? Sophia is the first AI citizen of the world. She is a system that has citizenship of Saudi Arabia, also a passport of Saudi Arabia, which is, I think, quite funny because Saudi Arabia doesn't treat women particularly well. And here you have a female robot and it gets all the rights. So yeah.
So the students are saying that Sophia looks very creepy. Maybe we could talk about the Uncanny Valley a little bit.
Yeah, sure. I mean, that's one of the research fields that I'm quite interested in, and we have been researching as a team. So Sophia indeed looks quite creepy, and this is something that we're very much exploring. I mean, scientists are really thinking about it because many robots look very creepy to us, and they look creepy for a reason, because they have this capacity of looking almost human-like, right? So they're not there really in terms of looking fully like a human, but they're almost there. And this almost triggers a specific reaction on our side, right? So when we see something that we cannot classify as human or non-human, then we become a bit eerie and we're like a bit stressed out and confused about it. And this is exactly the reaction that Sophia very often generates in us, right? But what we have done, for instance, as a team is we were looking at whether it's only limited to robots or whether chatbots, for instance, or any virtual system could be also perceived as creepy because it looks like a human. And in fact, yes, even if it's like a virtual character on your screen and it emulates, let's say, by emulation, I mean it simulates, it looks like a human and it makes gestures of a human, but it's not fully there, then you're gonna be triggered and you're gonna notice it in a second. And then your body will respond to like, oh, I don't want it, right? So even when you think about systems that are only using voice, like for instance, Alexa or Google Assistant, when this assistant starts to speak in a slightly different way than you expect, so for instance, says something in a sad voice that should be said with a, joyful voice, then you're going to be like, oh, there's something wrong. There's a context lacking here. This speech emulation is wrong, and my body reacts with like, oh, I don't want to deal with that, right? So we have a lot of that because on one hand, we're trying to build AI systems that are going to behave like humans, because human is ultimately the only reference we have. We can build systems that will look like animals or like humans, anyhow, like living beings. We want them very often to be like living beings. They are not there yet. And because they're not there yet, your old evolutionary system that responds for fleeing when something's wrong is going to be like, red light, just run away from this thing because it's a zombie or it's sick or it's dead, right? So that's exactly the response that Sophia is getting whenever she appears on the screen. You can find her like interesting or amusing, but nobody would like to be with her in one room just on their own, right? So that's what the Uncanny Valley is sort of about. But yeah, in many ways, I think Sophia is also very interesting and one of the most inspiring robots, at least for me, even though very simple. All right, can I move forward?
Yeah, sure. Go ahead.
All right, cool. So if you ask me what AI is really about, this is what AI is, okay? So less, I guess, interesting than Sophia, but indeed AI at its core is just very often a neural network, okay? So we've had some systems in the past that didn't look like neural networks, but let's say since the 80s of the previous century, so 1982, 83, people got super inspired by biology, and they said, all right, biology is something that we should follow in artificial intelligence because the way it organizes information processing is very efficient. You just have this small jello here, right, inside your skull, and it does so many cool things. And then you have some sort of supercomputer that takes the whole room and it does so much less. Why is that the case? So in fact, already in the 40s of the previous century, some people were saying, okay, we should, instead of building architectures or AI systems that are typical, we should try to look at the human brain and mimic it. Bring on board something that would be human brain-like. And indeed, that was the first concept of artificial neurons. And now we have whole artificial neural networks. They're usually consisting of layers. So you have quite a few layers there. You have layers that are going to be external, the input layer and the output layer. And in the middle, you have the so-called hidden layers. And all these layers are kind of bouncing back and they're networking and they're forming different combinations between themselves, pretty much like neurons in our brains. And through that, they process information very efficiently. And they can categorize speech, or they can detect that what they see is like a turtle and not a dog. And they can learn to do certain things better because they have this architecture that resembles a human brain. So architecture of the so-called artificial neural network. We have many different neural networks, and they're built in different ways. Some of them are built just to take care of images. Some of them are built to be able to synthesize speech, so to speak. Some of them are going to be responsible for translating from one sentence to another. Some of them will be responsible for detecting what kind of emotion you might be in when you're saying something. And they will have different capacities and functionalities, but they're all artificial neural networks. And because they're so efficient and they work so well, our AI has become so successful as a field, right? Because they are really working well and they're learning very fast to do certain things that we want them to do. And because of that, currently we have this very boom of artificial intelligence that everybody's so interested in. All right. So when you see those artificial neural networks, perhaps you're going to have it like like you won't have a hard time, let's say, answering this question. What do we mean by artificial intelligence? What could we classify as something that is artificially intelligent? And indeed, the answer lies in adaptation, right? So when you think about AI, what we expect from AI and what is different from just solely automated systems or IT, right, information technology, is that you're building systems that are going to learn and over time be better, right? And they will be able to eliminate the noise and learn all the necessary things to do what they're supposed to do. And when you think about, for instance, robots, in the past, robots were just all about performing the same fully programmed task, putting this there, then putting it back, putting it there, putting it back, right? Always the same thing. Now you can have a robot that's going to enter a room, see how many people are in the room, see and observe how they are behaving, see what obstacles are in the room and how to kind of omit those obstacles, how to go up the stairs, and so on and so forth. And these are adapting systems. So we're expecting adaptation, and well, artificial neural networks allow for this adaptation. It was never really possible before, right? That degree of adaptation and learning. That's why you have systems that are masters in playing the game of Go, masters in Dota and other MMO games, because they've been able to learn over time to perform tasks efficiently and very well. All right, so this is maybe a bit boring, but let me go very briefly through it, okay? So what's in the field? As I told you, artificial intelligence is very vast, right? And if you decide at some point in your life that you would like to study AI, you're gonna need to choose what you would like to do, right? So there are many things. So for instance, I'm doing a lot of natural language processing. So I'm dealing with text. I'm dealing with textual chunks of data. So I'm just taking a lot of text, I'm mining a lot of text to kind of teach the system how to, for instance, either speak better or how to extract information from the text, which means if you make AI system read a book, then you will want the AI system to summarize the book for you. So you will say, what was that book about, AI? And AI will tell you, this is what the book was about. I read through it and I extracted the proper information, not just some sort of weird sentences that make no sense, but actually it will be able to tell you what the book was about. This is something that we do so well as humans, and AI wasn't able to do that back in the day, but now it can. So natural language processing is definitely very important, and it deals with, as I wrote here, information extraction, but also with translation. So translating from one language to another. When you think about Google Translate, it was doing a really poor job when you think about translation. But currently, we have systems that are able to translate one sentence from one language to a sentence in another language that will actually work. In a sense, it will mean what it's supposed to mean. It will not be random or silly, right? Just direct translation, but it will be put in the proper context. Because when you think about Polish, mam węża w kieszeni, for instance, right? It means something. And the new type of system will tell you what this really means in English. And it will not have you will not have this direct funny translation like dziękuję z góry, thank you from the mountain, right? I mean, that's silly, but that's what AI used to do. Currently, not the case anymore. All right, what else is out there? Speech, definitely speech. So text is one thing, but speech, the way we speak, is another. You can have many systems that are going to record how people speak in different ways, because all of us speak differently. When you think about how you speak English, for instance, all of us have different accents, right? Because they're like influenced by our lives, right? I mean, in the past, for AI, it was not possible to detect someone speaking English if it was not like proper American English, because it was just fed either with that data or just, I mean, very limited in its skills. Currently, you have so many samples of people speaking that AI system can really adapt. So when you put Alexa in a household, right, and any type of household really, or any other system, I'm just looking for my own Alexa right now, but maybe I'll just give it a, okay, I'm not gonna, Alexa is very, you know, I mean, when she starts speaking, she never stops, so I'm not gonna turn her on. But when you think about Alexa in a household or any type of robot or like, you know, Google Assistant, then this system is going to speak to you no matter what your accent is, really. And that's very important. And that's the thing that has also changed. Now, what else is out there? Obviously, robotics, right? Clearly, but only that kind of robotics that learns. Machine learning, as I understand, you were talking a bit about it, right? I mean, so you said a bit about what techniques we have.
Well, we were just preparing to know some terminology before you joined us, so that it's easier for the students to understand you.
Sure. So machine learning is actually this fundamental thing, right? So it's not really even a path of AI. You could call it a path or discipline, because when you think about asking about the future, how the future will unfold, you need machine learning system and data to answer that question. But machine learning is also something that is a pillar of new vision, new speech, and new natural language processing, because we had those disciplines in the past, but they were not working that well. Only because of machine learning and the development of neural networks, we have the capacity to teach systems now. And in machine learning, you also have different ways of dealing with it. You can have a very statistical approach, which will be supervised learning, which will be very controllable and very simple in a way. And then you can have deep learning. And deep learning will be those neural networks with many, many layers that are going to process huge amounts of data, and out of that, learn really well, right? So that's different, that you can do it in different ways. All the newest progress in AI, everything related to speech, to natural language processing, or to machine vision is dependent on deep learning, all of that. So machine learning and deep learning specifically is like the fundamental thing in all of AI, sort of. All right, so machine vision, it's yet another very important discipline. So probably you know this term of deep fakes, right? Where a machine can generate an image of someone like Barack Obama or like Donald Trump or Mr. Kaczynski, right? And then this video is going to be fully fake, but it's going to be unraveled so well that you think that you're looking at something that is a real footage of someone speaking. And I think it's also a very interesting discipline, right? So the networks that can do it are called GANs, general adversarial networks. So they can process image and create images. But there are also other types of networks that can classify image. So they can say if what they're seeing is a turtle or a mouse or a chair, for instance. And that's very much used, for instance, in autonomous cars. Because when you think about autonomous cars, what they can do is they can indeed recognize whether they see a human in front of them or not. Sometimes they make mistakes, but in most cases, they don't. Let me just try and show you, because that's kind of interesting, I think, and cool. So I recently...
do you want to stop the presentation so that you're more visible?
Yeah, just for a second, then we will come back to it.
Yeah,
I wanted to show you something.
I'm going to stop the presentation.
Hopefully you'll be able to see it. So, all right, so just want to show you, because in this book of mine, Jakub de Barbaro, who is a great artist, has worked together with many programmers, and they're specializing in image, which I am not. And they've created, with this GAN network, they created images of me, and it was making many attempts. So here it received 60 images of me, and it was trying to recreate me, okay? So as you can see, the beginning is not so good, right? I mean, very
not so good.
Not so good. Here again, not so good, but it made attempts. So here it's attempt number 8,000, right? Here is yet another attempt, right? A bit better, gets improved, right? I mean, over time, you see that those images are better and better. Still not fully there yet, but really well. So here, it was still like making a mistake, but already reconfiguring the face quite properly, right? So you could figure out that that's definitely a face of someone. Here you can have more and more attempts. Look what happens below. This is actually me, right? This is an image of me. And here, that's the final version. Huh? All right, so that kind of matches, I think. So as you can see, these networks work really well. Yeah, sorry.
Were you telling the network that it was wrong, or so it was figuring it out on its own?
DC-GAN works on reinforcement learning, so we were just providing data. There's a bundle of algorithms that tell these networks how to learn, but we're not supervising anything over there. It's just free flow, right, of this system, and the system works, which is
That's
great,
amazing.
right? Which is kind of great, but kind of dangerous as well, right? So it's both. Let's come back to our presentation. Just wanted to show a few more things, probably not all of them, but just a few more things to you guys. Are we there? All right.
Yeah.
Start presentation. Here we are. All right. Let's move further. So just a few examples so that we're on the same page. Machine vision, as we were saying, mainly, or computer vision, some people say, but it's not fully adequate. Machine vision is mainly about object detection. So it's finding who is out there on the picture, right? Very often we do that for AI. So when you think about CAPTCHA, for instance, when you think about how you need to show that just for security reasons that where in that picture do you see, let's say, red light? You're usually doing that, right? You're pointing to it. At the same time, you're teaching a machine to do it better in the future. Always remember that when that happens, when you're doing this stuff, it used to be just for the sake of safety, to check whether it's a human or not a human trying to log into a given page. But currently, it's also for another reason, for AI to know what it sees, especially when the picture is blurry. People are great at distinguishing what is out there on that picture, and machines are not so great. So we're helping them in a way, whether we want it or not. And here's a great example of a case that is very confusing for AI, right? As you can see, that's the so-called Chihuahua versus Muffin challenge. Okay, so that's my students' favorite challenge, and they love it. Nobody has solved it yet fully, so it's very hard to teach a machine to recognize it properly. It's really struggling because the way it sees world is very different from the way we see the world. And because of that, certain relations between, like, let's say, different objects and their distance is very important. And here it's actually very misleading, right? For a 3-year-old kid, it would be like banal to solve it. But for AI, it's quite hard, really. So maybe you will be the ones who will solve Chihuahua versus Muffin challenge at some point in life. We can't. When it comes to natural language processing, so that's, I think, very interesting. I told you about machine translation, about the poor job that Google Translate was doing. I encourage you to check out DeepL. DeepL is the system that is translating in this new way. It's based on neural networks. It has been taught to translate for 6 years, and it can really translate well. So what you can see here is that even though I didn't finish my sentence, the system already guessed what I mean, right? So I was saying, hello, how are you, right? But without the you. And here it's already witajcie, jak się macie, right? So it's really smart that way. And many new systems are like that.
Is this system available to anyone?
Anyone. Just, search it up on Google, DeepL. Anybody can find it. Anybody can use it for processing small amounts of text. But if you want like a big amount of text, you need to buy the pro version. But essentially, it's like accessible to anybody. It works in some languages, I think in 6, but Polish is one of them. So
Okay, I'm going to post a link to it then on our chat. And you guys can check it out.
Okay. All right. So we spoke about Alexa, and obviously it's a very, very impressive text-to-speech solution. I don't know how many of you are experienced. I know Amazon doesn't work that well in Poland, but I have to tell you that whenever I'm in Massachusetts and I'm like shopping there, I'm usually using Alexa. So I'm just telling Alexa what I want to get, and then she says, "Okay, Alexandra, confirm," and then I get my food, right? So it's a different kind of shopping, and I think very useful in times of pandemic and social distancing. So and robotics, obviously a very important field. We spoke about it very briefly. So some of you might know it, but the greatest inspiration in robotics right now for AI people is obviously Boston Dynamics. It's like a dream company that is very secretive. We don't know much about it. I actually had a chance to visit, but just bits and pieces of it. I wasn't able to see everything because they're very, like, they have those NASA contracts, DARPA contracts, and they're very hidden. But they're producing those incredible systems that can really walk so well, and they can jump, and then they can move around and avoid obstacles and so on and so forth.
Yeah, and if you push, If you push them over, they are able to stand up on their
Yeah,
own as well.
they're very resilient. They're super resilient, that's for sure, right? So they can really keep their balance well. That's one of the core algorithmic issues that this company has really digged and solved very well. So they're really dope that way, I would say. And they're doing a great job. So MiniSpot is supposed to be kind of available. Many of their robots are already working, for instance, in Amazon, in the storage somewhere. So they're like moving packaging and like they're just moving things back and forth and carrying something that is too heavy for a human. That's something they also are able to do. All right, and machine learning.
Can I just interject for a second? There are some videos showing the robots on YouTube, but because a lot of it is so secretive, there is some like fan-made content. So if you guys check out Boston Dynamics, make sure it's an actual video. There's a lot of videos of robots that don't exist or behaviors that are not real online on YouTube. Not everything. Not everything that's out there is true.
They're definitely they're sending some footage on their own, but
Yeah.
obviously many people are like they have like huge fandom, so people are thinking about them. It's like very obsessive, So you'll find a lot, but check out Untapped, which is great, and MiniSpot as well. It's like marvelous work, really, in robotics. Okay. So what else? Machine learning, just to make sure that kind of you understand how much AI there is in your life, whether you know it or not. I just wanted to say that Netflix runs on unsupervised learning. Okay, so all the recommendations that you're getting when you're watching movies on Netflix are based on a unsupervised learning technique called clustering that is trying to, let's say, find similarities between you and other people, and through that make an educated guess about what is it that you would like to watch, right? So there is no human making those recommendations. That's definitely all AI. And Netflix is a very AI native company, right? The same for Amazon. When you're shopping online, all the recommendations for next products, that comes from AI. When you think about, for instance, credit cards or debit cards, perhaps that didn't happen to you, but your parents, that quite often happens to me, that when I travel, now I don't because the borders are closed, but when I travel, my credit card gets to be banned very often. I have a ban because I just made a transaction from a different place. And that's called anomaly detection in AI, which means whenever you're usually shopping in Poland and all of a sudden you're shopping in Thailand, an AI system reacts immediately by just, suspending this transaction and banning you from using your card because it wants to prevent a situation where somebody else is using it. And it's like, obviously very often it's like very much an overreaction, but nonetheless, it's very interesting. I think it's one of the algorithms in supervised learning, anomaly detection, that's what it's called. So very often it works too. So wherever you look, really, Netflix, online shopping, banks, even weather forecasting is based on regression, which is a supervised learning technique. You have it in many different places, right? AI is in many places, even though we don't know it really. So that's, I think, quite interesting. So I'm gonna just tell, because our time is up almost, but I wanna share just a few quick trends about what's about to be important in artificial intelligence in the future, okay? So one thing is that what you can all expect is that in the future, learning AI will not be hard. It will be simple, because now many people are working on creating AI-based tools that are not for coders, which means they don't require you to code to, for instance, build a chatbot, to create a robot, to create an application, to create a recommendation system, whatever you would like to do. In the future, you'll see more of AI that is really simple. Another thing is that's very interesting interplay. We're saying very often, in which season are we when it comes to AI? Some people say that currently we're in the summer because AI is thriving, right? Everybody's interested, everybody's loving artificial intelligence. But we also had, let me skip this, winters in artificial intelligence, right? So it's always like we're making a guess. Will the future be about a long summer and short winter, or the other way around? The winters mean that actually people overpromise too much, and it turns out that they cannot bring the solutions that they're like proposing or they're like promising, and therefore people are not so interested in AI, and they're actually quite furious about it, right? So then money ends and nobody's interested. And there were already 2 winters in artificial intelligence, and both of them were very productive because when you lack funding, you suddenly become super creative. But indeed, the future, I think, is looking bright for artificial intelligence. But if we don't deliver what we promise, we may have another winter. So it's important to remember these terms: AI summer, AI winter. It's like, the momentum. What is also very relevant is quantum computer. You may have heard about it. It's like a new way of information processing that is not going to be binary, but it's going to be 0 and 1 at the same time based on quantum entanglement. These computers are going to be super fast. And if they really start working, they're going to solve many problems that are really not solvable today, which means, for instance, for me, sometimes to process certain data, it could take even months. With this computer, it will take minutes. So that's important to remember. These computers are almost out there. Microsoft, IBM, some other companies are working on them. Okay, what else? Biology and artificial intelligence is also very interesting. Recently, we had the first development that was major in a discipline called artificial life. So not artificial intelligence, but artificial life, which means combination of real organisms and program. And actually, these things that you see here, they were built from stem cells of frogs. So skin stem cells and heart stem cells, and AI was choosing the proper mixture. They didn't have any nervous system. They were not, taking in any food. They were not replicating. They would just exist and then cease to exist. But nonetheless, AI was creating different versions of them. So it was first fully programmed living creature, right? Very simple, but it was there. So it's important to think about that as well. We will have some issues, right, when it comes to AI. I don't want to dwell into that, but we have a lot of topics in ethics of artificial intelligence, right? I mean, when you think about certain dilemmas, if AI is becoming smarter and smarter, then it's going to make very important decisions also about our life. For instance, whether your parents could get a loan in a bank, whether an autonomous car should drive or stop, right? Risking, for instance, somebody's life. So all these issues are going to be very, very relevant. So we have a whole big field of artificial intelligence ethics today, right? And it deals with all that stuff. It also deals with stuff like the fact that I told you that we have all those artificial neural networks and they're super smart, but at the same time, we don't fully know how they work, right? So we don't have transparency, which means we're building systems that magically work, but we don't exactly know how. We just know that they learn so well because they can do this thing, right? So out of blurry images of Alexandra, they can create a perfect image of Alexandra, right? Or almost perfect image of Alexandra, like this. And that's quite interesting, but at the same time, it's scary that AI can be doing so many things without any human control or supervision. Okay, and then maybe the last thing that I would share with you is also related to ethics. We don't want in the future artificial intelligence to discriminate anybody, right? It has happened in the past. So really, it's very important for us to build systems that are going to be fair, right? And that's a big question, how to build such systems, because humans tend to be unfair very often, right? So if you want to build a system that is going to make good decisions about whom to hire, whom to recruit, which of the candidates to choose, you need to make sure that you have a very balanced and diverse system, because otherwise it's going to be biased, and we don't want that. Bias has happened. For instance, in Amazon, they built a system in AI that was supposed to recruit new people to the company, and the system would not choose any woman for the company. You know why? Just because it was not fed with any data related to female workers. So it was just lack of imagination on the human side, but then it caused a lot of drama and a lot of problems, I would say. And therefore, it had to be closed and withdrawn from the market, at least for now, until it builds itself some fairness. So these are like sort of the issues that I wanted to tackle with you guys. Like, this is why AI is special in so many ways. Yeah, and I just hope you liked it.
Okay, we'll stop the presentation for now. Thank you very much. I can see by the comments that our students were really engaged in your presentation, so thank you very much. Maybe just one last question from those that were coming up. The students were asking what you think about Black Mirror, about that series on Netflix. Are you watching it? Do you think this is our future?
So, that's a tough question. I do think there are some episodes of Black Mirror that are speaking to me, okay? And they're scary in a realistic way. So when you think about what the Chinese government currently does, how it supervises all citizens through image processing using AI, that makes me feel scared. And that's actually one episode of Black Mirror that I saw. And it's like reality. But for the most part, I think it's a great show, but it's a show about only one possibility or outcome of how AI could work, okay? So we see many benefits. We see how AI can diagnose diseases. We see how AI can bring about bionic hands for people who are handicapped. We see many positive things about how artificial intelligence works. So there are many future scenarios, and it all depends on us. Black Mirror shows you only the black scenario, the dark scenario, but there are many other scenarios, and we're making sure and trying to work on those good scenarios to be fulfilled.
Okay, great. Thank you very much. Thank you for speaking to us today, and
of course.
Have a great evening and stay healthy.
Thank you. Guys, if you feel like studying artificial intelligence, feel invited to do so with us in the future. If you feel passionate about this topic, we're definitely a very dedicated team of people, and I hope at least some of you will at some point decide to kind of be involved in the artificial intelligence community, because we need more talent in it.
Okay, great. Thank you very much.
Thank you.
For
Thank you.
us.
Bye.
Bye. Okay, so that's it for today. Thank you so much. The recording will be available on our platform, and have a great evening.